Alright, welcome back to our video. So working on horizontal and vertical asymptotes with you there to help you out on this assignment. And let's see here. Shout out to Ryan for helping us get this sorted. Let's see, so just another reminder before we jump into the harder ones that the horizontal asymptote, the HA, has to do with the powers, right? The powers are degrees. And so, for example, for number 6, since our powers equal each other, then we just use the numbers in front. And so the numbers in front is an invisible -1 and then also a positive 1. So y equals -1 over 1. Nice. And then to find the vertical asymptote, you just set the bottom equal to 0. So in this case, you would factor it and factor the bottom, set them equal to 0. Cool. But, so the advanced part now is, for example, number 10. And it kind of already has an explanation on the worksheet for you. But just in case. So number 10 does factor into x and x. Factors as 10 is 2 and 5, positive, negative. And then x squared plus 8x plus 15. Factors into 3 times 5 is 15. Good. Cool. So we would have vertical asymptotes, VA for vertical asymptotes, at x plus 3 equals 0 and x plus 5 equals 0. So that would be minusing 3 to both sides. So we get at -3 there's a vertical asymptote. And at -5 there's a vertical asymptote. However, it turns out it's not quite a vertical asymptote there. And the reason why, so -3 there is, but at -5, if we go up here and look at where that -5 came from, this factoring right there, because it's in the bottom and the top, then it's not a vertical asymptote, it's actually a hole. So we wouldn't circle it, we would just list it as a hole. And what I mean by hole is like when the graph comes down, and then there's a hole kind of right there. That looks like a closed dot. Let me do a open dot hole. There you go. Like that, yeah. So that's, so basically there's a hole there instead of an asymptote. Yeah, doing a video. So be careful with the holes. So for example, on the back side, take a look here at number 15. So number 15 actually is the difference of cubes on the top and then regular factoring on the bottom. And so on the bottom we get x and x, and we get 2 times 3 is 6. Let's make them both negative to get that -5x there. And then on the top it actually uses a formula. It's called difference of cubes. And so you just use the formula instead of factoring. And so it's a minus b times a squared plus ab, a times b, plus b squared. So, well, what's your a and your b? Well, your a and your b come from this factoring here, where x times x is x squared, and 2 times 2 times 2 is 8. And so therefore your a is your x, and your b is your 2. Nice. So to factor this one, you just do x minus 2 is what that factors into, times x squared, plus x times 2, or 2x, and then plus 2 squared is 4. Now the reason why we did the factoring the top, because you usually don't have to do the top, you only have to factor the bottom usually. But since our vertical asymptote, right, our VA, vertical asymptote, it was going to be add 2 to both, set them equal to 0, add 2 to both sides, add 3 to both sides. So it was going to be at x equals positive 2 and positive 3. But it's only going to be at 3, right? Only at x equals 3, because x minus 2 on the top and the bottom cancel. They go away. And so that's not an asymptote anymore. It's a hole. And so we're going to circle x equals 3 for our vertical asymptote and not 2 because that's a hole. So just wanted to make sure that you see that. I also graphed it on my calculator to show you the hole. And so here's a copy of it. Let's take a look and zoom in. So this is x cubed minus 8, the graph, x cubed minus 8. And then, so x cubed minus 8 all over x squared minus 5x plus 6. So here's what that graph looks like, and you can clearly see it. What? Yeah, so it's not an asymptote. The line doesn't follow an asymptote, but there is clearly a hole in the graph right there. Crazy, cray-cray. So that's pretty crazy. And so, yeah, so don't circle that as a vertical asymptote, because if it was, it would be right here, right? And if it was, then the graph would follow along it. But it's not. Yep, it's not a vertical asymptote. It's just a hole there. Cool. And you'll see that more when we're graphing these suckers. Cool. So there's number 15 to help you there. Another one to help you is number 17. And let's see here. So for number 17, let's delete this here. So number 17, again, we factor the bottom. So we get x and x. 6 and 1. I'm thinking they both need to be negative. And so that's to find our vertical asymptote. So to find the vertical asymptote there, we get add 6 to both sides. So we're going to get x equals 6 and x equals 1. But one of them might be a hole and not a vertical asymptote. How do we know that? Well, we also factor the top. And so when we factor the top, we get 1 times 3. And we need the 3 to be positive, the 1 to be negative. Uh-oh. So since there is an x minus 1 on the top and the bottom, that means they divide by themselves. Just get 1. Goes away. And so that means that this is a hole and not a vertical asymptote. So we do have a vertical asymptote at x equals 6, but not at 1. Not at 1. Cool. And then also the horizontal asymptote. Well, this one's pretty easy. The powers are the same. Excellent. Oh, and before I forget, this light seems to go out every once in a while. It's okay right now. Just the one closest to my door. Yeah, I think it's the. Yeah, it's like the right. I think it's the right or left bulb. I can't remember. Yeah, cool. Thanks. Have a good one. Yeah. What was your name again? Helaman, immortalized on my video forever. Thanks. Yeah. Just your voice, don't worry, just your voice. Yeah. Peace out. Okay, let's see here. So also don't forget the horizontal asymptote is the other one that you need. And so since the powers are equal to each other, they're both 2, right? So powers equal. That means you're just going to use the numbers in front. So just the x squared, just the 1 and the 1. So then y is equal to 1 over 1. And so that just equals 1. And so that's our horizontal asymptote, just y equals 1. Cool. And then I didn't do that for 15, so let's show you that one real fast too. Sure, give me 2 seconds. I'm almost done here. Just 2 seconds. So then the horizontal asymptote, ooh, so for number 15, the horizontal asymptote, the top power is actually greater than the bottom power. And so that means that the horizontal asymptote is so y is equal to none is the correct answer. Or they could put oblique or slanted. And so that's the correct answer there for the horizontal asymptote. If they wanted to get extra credit, if you want to get extra credit on these slanted ones, you could actually find the equation. And so you have to do x squared minus 5x plus 6, and then into x cubed minus 8. Don't forget the placeholders. That's 0x squared and 0x to the first power. And so x squared goes into x cubed, x times, good. And so then that'll be, x cubed minus 5x squared plus 6x. But then you have to change the sign on those. So that becomes negative positive. So then that'll end up with a positive 5x squared. And then x squared becomes 5x squared with a plus 5. So extra credit would be the slanted equation, y equals x plus 5. I know there's a remainder and more to it, but I'll give you extra credit at least just for finding the line equation. Cool. So take a look there and keep working on these problems. Ask questions in class. And thanks for watching our video. Hope this helped you on horizontal asymptote and vertical asymptote. And then what was your name again? Taking the driver's ed test. Yeah, Lucy, you're immortalized. You're on my video. Sign up for New Build next year. Yeah. Thanks for watching. Peace out. Bye for now.